My name is Frank Mills. I'm a consulting engineer and I'm on NHS Improvements and NHS Futures Group, looking at how we can improve things across the NHS. So ever since the start of COVID, I really got involved because my background is ventilation, mechanical engineering, construction. Been doing that for about 50 years. And I got involved with a number of different groups there in the UK and also overseas. ASHRAE is the American Society of Heating, Refrigerating and Air Conditioning Engineers, and they have a COVID task force which has done an enormous amount of work and has a website with a lot of information available on it. So really what I want to talk about today is how we all started on this route of trying to look at coronaviruses and COVID-19 and what we could do, particularly in the building and with ventilation systems to try and reduce the risk or eliminate it, and how we could apply that specifically to hospitals and COVID-19 patients. There is also another related issue in the reoccupation of buildings after lockdown, which we covered as well. Buildings have been empty for quite a long time. When we went back, we have to really check them out, but we've also got to make sure that they are all right to occupy. And that did involve updating ventilation and looking at what we should be doing. It really breaks down to three basic elements: human beings, our environment, and our health. And we have to be aware that modern buildings are quite sophisticated. They do have complex engineering systems in them, and within those systems, they have specific items of equipment. And in the UK, we don't always look after these things properly. We do have to make sure they work every day for their life, and their life in use might be 25 to 30 years. So it's a big task, and I don't think we're always very good at it. It surprised me in this journey that I took over the past 2 years to find that over half of UK hospitals don't comply with our basic ventilation standard of HTMO3. In fact, the figure is 55% don't comply, and there doesn't seem to be any plan in place to bring them up to scratch, which I find surprising. So during this journey, we had to find out what COVID-19 was or is, and we found it as a highly infectious respiratory disease that causes serious illness and deaths. And being an engineer, I interpreted the respiratory bit to be in the air ventilation, and I looked at the equipment we used and what we could do about it. We are now living with COVID and it's still around, so we've got to make sure that the buildings we've got do function properly, even with that in the air. I think what the options we have available to us are threefold. We have the vaccines developed very quickly and successfully. That was a big result. An alternative option might have been to actually just take it out of the air altogether, so we can filter it out. We can deactivate it using UV and other cleaners so that it doesn't exist. So the air that's being in a room with someone with COVID is clean, so no one else catches it. So that's another option, which we didn't really follow. We could do both of those things, which is obviously what I'd like to see done, because that reduces risk, brings us back to normal, but we can have the vaccines as well to make sure we're covered. When we look at how we could take it out of the air using engineering systems, there's three basic options to us. One is to have lots of fresh air. And actually, when we look at the HTMO3 standard for treatment rooms and others, it talks about 10 air changes per hour minimum. That's fresh air, by the way. So really, it's bringing in air from outside into a room like this 10 times every hour. So every 6 minutes, all this air is thrown away and new air is brought in. So it's a big energy cost, but that's what our standard asks us to do. For operating theatres and the likes, it's more like 30. For wards, it's 6. So our standard does require a lot of air, and what that air is doing, it's diluting whatever's in the room. Gases, pathogens, dust and dirt, all that outside air is coming in and diluting what's in there. Of course, it's also bringing in what's outside, so we have to think about that. In order to make that happen in places that don't have those systems, is major works involved. We have to put big engineering plant on the roof or somewhere, and of course that's going to cost us more energy to do it and produce more carbon. And I say that because if we were to look at the 55% of hospitals that don't comply, we would see a very high increase in energy and carbon emissions. And bearing in mind what we've just heard there in that last talk, we don't really want to do that. So we need a more efficient way of doing it. So an alternative would be to look at some kind of air cleaning device. So UVC is a method of cleaning the air using ultraviolet light, which I'll talk about in a minute. And it's a low-cost option because we could simply do it by wheeling a device into a room like that, locating them around the room, and then we're cleaning the air locally by deactivating viruses or killing off bacteria. And the third option available to us is HEPA filtration, where we put a really high-grade filter into a device, which could be like this one again, or in our plant, and that just takes the biohazard out of the air. So there are three basic options. When we look at ventilation, the HCMs do encourage us to use natural ventilation as far as possible. And so we got this question mark, is natural ventilation the best way? Open the window, let the air in. Will that do the business, or should we be looking at mechanical ventilation with these devices to clean the air? If we have natural ventilation, we're not really cleaning the air because outside air will just come in through the window as it is. So as it enters, it hasn't really got any COVID in it. That doesn't come into the air until someone with COVID walks into the room. But you're relying on this outside air to dilute that and pass back out. So natural ventilation is a bit mixed. And if you look at any UK hospital, you'll find there's only about half the areas maximum natural ventilated. And they're really ward areas and non-clinical areas. So all the clinical areas are mechanically ventilated in some way, or should be. So when we look at these air change rates, we realise they're quite high, and they have this energy and carbon cost, which I mentioned. So coming back to what we could do to reduce that, we could look at air cleaning locally, which would enable us to reduce the outside air rate coming in. So instead of having 10 air changes, we maybe have only 5. And the other 5 could be dealt with by a device like this, which is cleaning the air locally. When we start to look at the two options that I mentioned, UV or HEPA filtration, we find there's mobile units which can just wheel and plug in. So this is fairly convenient. You could order this online, take it out of a cardboard box, plug it in yourself. You don't have to order through a big construction company. But it's in the way then, and many of you are aware, in many hospital areas there just isn't a spare plug, and nor is there a spare wall space. So where do you put them? You can find places you can put them high up on the wall and bolt them on, but a better option would be to put them in the ceilings out of the way. So this now requires some ceiling coming down, electrical work to wire it up, and then to make it work like a recirculating air cleaner in the ceiling. And then the third option would be to put it in the ductwork. So if you have a mechanical ventilation system, you can actually cut a piece of duct out and slip in an air cleaner so that it's out the way and it's part of the system looked after by estates who will maintain it for you. So just talking about UV a little bit longer, we've known about UV through sunlight and others as a good method of killing off bacteria and deactivating viruses. And this is a brief history which I won't go through, but the work by Blunt, which is on the bottom left-hand side there, really initiated work to look at it for healthcare. But we haven't really picked up on it much in the UK, although it has been used commonly in America and the Middle East. So this is a chap called Kowalski, who's really written a lot of work on this, and this would be a good reference to look at if you look at this article explaining how the technology works. So this is well and truly pre-COVID. This was 2007, so it's been around a long time. Just really hasn't found its way into the UK. And if you really want some good technical data on UV, you really want to know what it means, how to apply it, not just the fact that the science works, but how to actually make it work in practice, I'd encourage you to look at the ASHRAE guides. This page on the right is part of a chapter of about 30 pages on UV air cleaning for air and surface treatment. So a couple of things to remember, technically speaking. Ultraviolet light sterilises air by killing bacteria and deactivating viruses, breaks their DNA chain. It is actually harmful to humans, so we don't want the light spilling out onto us as people, or anyone else for that matter. So we need to shield it. So any time you think of looking for a UV device, make sure the light can't get out of the box. The UV performance depends on intensity and dwell time. So just having a UV lamp is not necessarily the right answer unless it has the time and the intensity to actually deactivate the virus. So that really means that air's got to pass pretty close to the lamp, and the lamp itself has got to be of the right energy. This is a mobile unit in the corner of this care room. This is actually my mother-in-law, who's 95. So I brought this in and I plugged it in, quick and easy to install, low cost, easy to maintain. It's visible, doesn't make much noise, and it's protected her. In this care home, they did have 12 deaths actually from COVID, but she wasn't one of them. So I'm not saying this was the reason, but it certainly reduces risk. There's the only one in that care home, I haste to add. Going to UV in ceilings and in ducts, I prefer this solution as an engineer because now it's out of the way and it's part of the engineering installation, and it's not just a piece of stuff in the room. But this does require modifications, as I say, to get it into the ceiling, and it will have to be maintained regularly, lamps checked and replaced, and you need safeguards, so you need to make sure the kit doesn't allow light out, otherwise the maintenance operative could be injured. So this particular scene is in a hospital in Maidstone where we had a RAPS ward. Now that's a rapid assessment ward. This was in the period when ambulances were queuing up. Patients couldn't just go into the hospital, they had to be checked for COVID before they're allowed in. So what Maidstone did was to identify an area of about 6 or 7 beds where this could happen. And in that area, we put this installation in the ceiling to make sure the air was very, very clean. So the ambulances dropped people off, they were assessed, and then they were taken through into the hospital. This is a picture of an induct unit, which I think is the longer-term result, because now this becomes part of the engineering infrastructure. Doesn't concern any medical or clinical people because they now know that the air coming out of that grill into their space is clean. And of course, this has been picked up by other people outside of the medical profession. This is an office block in Chicago, actually. So the developer who's just finished this and he's got it onto the market, it's now occupied. He claims this is one of the first post-COVID-19 structures. It's designed with enhanced air filtration. They've got widely spaced offices to give people more room between each other. And they've got touchless features. So the property industry, or those people in particular, are picking up on that and realising this can be a good selling point, as well as giving people a safer, healthier environment. What about existing buildings, though? So there is work being done. This is office blocks in London, looking at how they can put in bespoke systems to cut down transmission and make those areas safer. And those results are coming back. So there's quite a lot of work going on in that area. And in fact, I should mention that Part F of the building regulations, which is ventilation, now prohibits any recirculation of air in an office or other space unless it is cleaned. But bear in mind, it's not retrospective, so anything new being built would have to do that. Now, I'm a member of the Institution of Mechanical Engineers, and we're upgrading our headquarters building, and we're looking to do this in a safe manner. Coming back to healthcare, we looked at dental surgeries in Birmingham, and we found that their rooms only had 5 air changes an hour. So we, first of all, found that the air was mixing too much. So the risk is really a patient lying there being worked on with a dental nurse and a dentist. So we wanted the air to go down. So we tried this swirl diffuser, and this picture is showing with the smoke there how the air has been blown down. But actually the bed in a dental room is fairly central. It's off to one side because of the furniture layout. So we developed this other type of nozzle. I know it looks a bit patchy with the silver foil on here, but this is really just testing it. And this threw the air 10 degrees sideways so that it came across over the bed. And we can reset those nozzles to give us the airflow we want. So that's the first thing we did, was to modify the existing ventilation so that it blew the air in the right direction. And then in that room, we added an air cleaner device, similar to one behind me, not this particular make, but one like it. So it picked the air up at low level, which is where all of the AGPs are going, cleaning it and blowing clean air back up into the space. So that's been fairly successful. We modelled this as well using computer simulation, and you'll just see on these graphs, if you look at the top left-hand corner, that's really showing the air cleaner, how the air comes in through the window. You can have natural ventilation as well, you see. This is Pride Hill Surgery, which is just near Shrewsbury. Air comes in, and that blue thing shows how the air circulates. The bottom left is showing from floor upwards where the cleanest air is, so the air's been cleaned. So I'm not going into great detail here, but the computer simulation allowed us to look at a number of different solutions, different types of grills, and to make sure that we were cleaning the room. At the bottom right here, it's not actually moving, but we can make it move. Is showing the particles coming out of that patient's mouth. The heavier ones are dropping, of course. The lighter ones are floating up, but they've been blown down by the air towards the floor. So there's been a lot of work done on this, and papers being published, and we are doing more work with Birmingham. Speaking as an engineer who's been involved in this, it seems to be some trusts do work and others don't, but then the information gets passed on and others start to pick up on it. So Birmingham have led the way with dentistry, as far as I can see. It's coming back to the filtration, HEPA filters. That works as well. They tend to use a bit more energy than UVC because the HEPA filter is a very thick filter which collects every bit of dust down to 99.99% efficiency. So that's really catching everything. Don't forget COVID is 0.3 micron. So I think the applications issue there for me is how do you clean the filter? It's great when it's sat there working, but one day someone's got to take that filter out. It might be after a month or 2 months. It may not be a long time, and then replace with a new cleaner filter. The one that comes out is a biohazard, so that's got to be disposed of safely. Just want to touch very briefly on this slide, which is an ASHRAE slide. Actually, it's showing the various pathogens on the left, and on the bottom, it's talking about humidity. It's a clearly understood fact that if we have low humidities, we tend to get viruses and bacteria transmitting. And again, if we have high humidity, we also get them transmitting. But there is this area in the middle between 40 and 60% where they don't transmit very well at all. So through my work with ASHRAE in America, this is something they're very keen on because they do a lot of humidity control, cold winters, hot summers. In the UK, we don't tend to do it. And I think the reason is that, first of all, we benefit from a temperate climate. So it just so happens that we're in that middle range for a lot of the time. But in cold winter days, we will definitely go down to low humidities of 20%. And in hot summers, when we have high humidity, we will go up to 70 or 80%, but not for long periods. So the medical practitioners have kind of accepted the fact that there's some risk there. But on the other hand, the cost and the complexity of putting in humidity control systems is something they've wanted to avoid. It sort of links to risks like Legionella as well in the ductwork. I just want to touch on work being done by the Royal Academy of Engineering, and I'm on a group here that have been looking at COVID, and we've issued one report to government. This is the initial report. There's a second report which is just about to be finished and should be out within about a month, maybe probably June actually. But that's been looking at infection-resilient environments. It's talking about the engineering aspects, the cost to the economy, the difficulty, whether our industry is actually equipped to do this kind of thing, whether we've got the right skills. But there is that work going on in the background. If anyone wants information, I can pass that to you. We've had example solutions of schemes with rooms with a pre-existing air change rate of 4, with a ceiling-mounted air conditioning unit, recirculating the air. So, as you're aware, during COVID, we were told to stop all those devices because recirculating the air was not a good thing. However, if we clean the air, we can actually go back to switching those things on because the air will be recirculated, but it will be cleaned in the process. We did put this standard together, which I can share. It's still a final draft, unfortunately. So I formed a group at the Institute of Mechanical Engineers of experts, and we worked with the NHS through the Chief Engineer, Mike Ralph, to produce this standard. And it's really about selecting and applying UV air cleaners. Someone said we should cover filtration as well, but I think that's well covered. So these are relatively new devices in the UK, and we want to make sure you got that right. And there's a proposal to do an applications guide now. So that's a quick run through. I think that engineering is a very important part. I don't really think we've done an awful lot in the UK, and I think our numbers have been, of deaths and illnesses have been very high as a result. I think we have a lot to do. And the fact that, in fact, our hospitals don't even comply with our basic standard, I think that's perhaps a starting point. So I thank you, and I've got my details on there. If anyone wants to contact me, I'm happy to share our work. Thank you.